So I will substitute x1 into equations 2 and 3. So we have 2x2 minus 6x3. So except for some of the algebra, some of this you'll just have to, at this point, maybe accept on faith, and then as we move along, hopefully the pieces will come together. Right? So that's just plugged in x1, did the algebra, this is what I end up with, and this should be a 2, not a 3. Okay, that makes sense, right? Everybody can follow along with that. So this was equation 2. So now we'll do equation 3. Okay, that makes sense, right? So then if I rewrite what we have, our new series of equations is going to be x1 minus 2x squared 6x3 equals 0. 6x squared, or not squared, x3 . Right, so first equation, second equation prime. So does that make sense? Coming up with this new series of equations. And now we're just going to use that first term in our second equation as the pivot. And we want to eliminate this. So we repeat the process. From equation 3 prime, right? So this goes 6. Well, let's do this. Let's see. Okay, so that's the value that the x squared or x2 value that I'm going to use to plug into x or our, let's see, our equation 3, which is, where's our equation 3? So we want to plug in right? So we've just substituted this for x1, x2. Now we can do some more algebra. Um, so, equation 1. Okay, so that makes sense. So now we've got our triangle, and we have one variable, and we can solve for our, or we have one unknown, right? So we can solve for this unknown. Once we know what x3 is, we can plug it in here, solve for x2. Once we know x2, we can plug in x3, x2, and solve for x1. Okay, so pretty straightforward, right? So let's do, so let's see, so solutions. So 15 halves x3, 3 halves, right? x3 is going to equal 3 halves minus or times 2 over 15, right? 6 over 30, so 1/5. So there's our first solution. So now if we plug that into our second equation, this is 3. There's x2. We can plug in for the last one. So x1 So now we have our solution for our system of equations. Easy peasy, right? So let's make this a little more complicated. Back over there. Hopefully that lines up. Okay. So now we can, one thing to note about this is Kirchhoff's, oh, now I forget the term. What's that? Voltage law and current law, right? Because you have, whatever you have going into a location has to come out of that location. So basically conservation of energy, right? In engineering or in mechanical engineering terms versus electronic terms or electrical engineering terms. So we can set up a series of equations that explains these loops, and then we can solve for the current at I1, I2, and I3 based on using current or Kirchhoff's voltage and current laws. So how do we set that up? Anybody got any ideas? What that might look like? So if we start with, so we have two loops, right? So we're going to want to separate it into the two loops, right? And deal with each loop individually. And we can say whatever's in and out, whichever way we want to do it. That's just our convention, right? That we choose as long as we're consistent about it. So let's see. Current